This is a tutorial on binomial distributions. A binomial distribution is a type of probability distribution. So to talk about binomial distributions, we have to know what a probability distribution is. A probability distribution is a function that describes the probability of a random variable having a specific value. So it is an equation that describes the probability of a random variable, let's call that x, of having some value. So x has to be equal to something, and our function will describe the probability that x actually is equal to that value. So let's look at an example. A card is drawn at random from a deck of 52. If only the suit of the card is measured as x, then the probability distribution would look like this. Here we have our values of x, and here we have the probability of getting that x value. So if x is equal to heart, well, there are 13 hearts in a standard deck of cards, so 13 out of 52 possible gives us 0.25. So if x is heart, the probability of getting x is 0.25. If x is equal to spade, well, there's 13 spades in a deck of cards. So again, that probability would be 0.25. The same thing if x is equal to diamond or x is equal to club. For each of these, the probability is 0.25 and 0.25. Frequently, probability distributions are expressed as histograms, or you can think of that as a bar graph. Along the x-axis, we have our different values of x, heart, spade, diamond, and club. On the y-axis, we have our probability. Notice that all four of our values for x all have the same probability. So now let's try building our own probability distribution. Let's look at all the possible outcomes of rolling two six-sided dice. Well, if I roll one six-sided dice, I have the possibility of rolling a 1, a 2, a 3, a 4, a 5, or a 6. If I roll a second die next to it, I also have a probability of getting a 1, a 2, a 3, a 4, a 5, or a 6 with that second die. So I have 6 possible outcomes with the first die and 6 possible outcomes with the second die. And that means that there are a total of 6 times 6 different possible outcomes, or 36 different rolls I can get with two six-sided dice. Now x is all of our possible outcomes of rolling these two six-sided die. So I can get a 2, a 3, a 4, a 5, a 6, 7, 8, 9, 10, 11, all the way up to 12 as a sum for whatever I get from the first die added to whatever I get for the second die. So if x is equal to 2, that means I'm going to add up my two dice and I'm going to end up with the sum of 2. Well, there's only one way to get the sum of 2. That's if I roll a 1 with the first die and then a 1 with the second die. So that's only one possible outcome. It's equal to 2, but there's only one possible outcome out of 36. So the probability of getting a 2 is 1 out of 36. Now what if I wanted to know the probability of x equaling 3? So how many different ways are there to get 3 from adding the sum of two different dice? Well, I could roll a 1 with my first die and then a 2 with the second one. Or I could roll a 2 with the first die and then a 1 with the second one. So there are 2 different ways of getting a 3 from two six-sided dice. Since there are 2 different ways, my probability of getting a 3 would be 2 out of 36. Or you can reduce that down to 1 out of 18. So now let's look at all the different ways I can have x equaling 4. Well, I can get a 4 from my first die being a 1 and my second one being a 3, or my first one being a 3 and my second one being a 1, or I can also get it from both dice landing up with 2. These are the 3 ways that my 2 dice can sum up to be 4. So there's 3 different ways out of 36. This reduces down to 1/12. So the probability of getting a 4 is 1 out of 12. Now we'll try 5. Ways to get a 5. Well, I can get a 5 from a 1 and then a 4, or a 4 and then a 1. I can also get it from a 2 and then a 3, or a 3 and then a 2. And those are all the ways that I can get a sum of 5 from 2 6-sided dice. And there are 4 of these ways. So my probability of getting a 5 then would be 4 out of 36. This reduces down to 1 out of 9. Now let's find the probability of getting a 6. Well, ways that I can get a 6. I can roll a 1 and a 5 and a 1. A 2 and a 4 and a 2, and a 3 and a 3. So there are 5 different ways that I can roll a 6. So my probability of getting a 6, well, that's 5 out of 36, because there's 36 total different rolls with the 2 dice. So now let's work on finding the probability of rolling a 7. Well, let's think of all the different ways we can get a 7. We can get a 7 from a 1 and a 6 and a 1, a 2 and a 5 and a 2, a 3 and a 4 and a 3. So here we have 6 different ways to get a 7. So the probability of getting a 7 is 6 out of 36. And that reduces down to 1/6. So the probability of getting a 7 is 1 out of 6. Now let's work on getting an 8. Ways to get an 8. Well, we can get an 8 from a 2 and a 6 and a 2, a 3 and a 5 and a 3, and a 4 and a 4. So there are 5 different ways to get an 8. So my probability of getting an 8 would be 5 out of 36. Now we got to work on finding the probability of rolling a 9. Well, you can get a 9 from a 3 and a 6 and a 3, a 4 and a 5 and a 4. So there's 4 different ways to get a 9. So the probability of rolling a 9 is 4 out of 36, and that reduces down to 1/9. Now the 10. We can get a 10 from a 4 and a 6 and a 4, or a 5 and a 5. So there's 3 different ways. So the probability of getting 10 is 3 out of 36. And that reduces down to 1/12. Only 2 more to go. We need to find the probability of getting an 11. Well, we can get an 11 from 5 and 6, or 6 and 5. So there's only 2 ways to get an 11. So the probability of getting 11, that's equal to 2 out of 36, or 1/18. And then lastly, we need to find a way to get 12. Well, we can only get a 12 from rolling a 6 and a 6. So there's 1 way out of 36 to roll a 12. So we found all the different values of probability for all of our different values of x. And if we wanted to express this as a histogram, it would look something like this. Notice again that our x values are on the x-axis and our probability values are on the y-axis. Notice that 7 has the highest probability. And then as we move away from 7, our probability decreases. But this is the shape of our probability distribution. So now that we know what a probability distribution is and what it looks like, now we can talk about binomial distributions. Binomial distributions are just probability distributions where the random variable, remember that's x, is measured only in success or failure. So if we wanted to set up a binomial distribution with the 2 dice, we would have to set up a binomial distribution that stated what is the probability of rolling less than 7 or greater than 7. Because the value of x can only be one of 2 different choices. That's why it's called the binomial distribution. Now, for solving for a binomial distribution, we have a standard formula. This means that the probability of r is equal to, now n choose r, this is a combination. P is the probability of a single success to the r power, where r is the number of successes we expect. And this is all multiplied by 1 minus p to the n minus r, where n is the number of possible successes. So let's look at how we can use this. Let's create the binomial distribution that measures the number of heads resulting from flipping a coin 5 times. Well, if we flip a coin 5 times, how many different numbers of heads can we get? We could get 0 heads, we could get 1, 2, 3, 4, or 5. Every coin would land heads up. So we would want to find the probability for all of these different possibilities. Well, the probability that we would get 0 heads, that's equal to 5, because that's the total possible number of outcomes, or the number of possible successes. Choose 0, because that's how many successes we're hoping to see, times the probability of getting 1 success. Well, you have a 50-50 chance of getting heads when you flip a coin, so this would be times 0.5 to the r power, which would be the 0 power, times 1 minus p, which again is 0.5, to the n minus r power, so the 5 minus 0 power. So the probability of getting 0 heads, well, 5 choose 0 is 1. 0.5 to the 0 power, that's also 1. 1 minus 0.5, that's still 0.5, and to the 5 minus 0 power, that's to the 5th power. 1 times 1 times 0.5 to the 5th power, that's equal to 0.03125. So if these are the values of x, then the probability of x, that's equal to 0.03125. Now let's work on the probability of getting 1 head. Probability of 1 head is equal to 5 choose 1 times 0.5 to the 1st power times 1 minus 0.5 to the 5 minus 1 power. So the probability of getting 1 head, 5 choose 1 is 5 times 0.5 to the 1st power, that's 0.5, times 1 minus 0.5, that's 0.5, to the 5 minus 1 power, or 0.5 to the 4th power. This comes out to be 0.15625. So the probability of getting 1 head is 0.15625. Now let's try to find the probability of getting 2 heads if we flip the coin 5 times. That's equal to 5 choose 2 times 0.5 to the 2nd power times 1 minus 0.5 to the 5 minus 2 power. Now 5 choose 2. Well, there are 10 different ways to choose 2 out of 5 possibilities. So 10 times. Now 0.5 squared is 0.25. And 1 minus 0.5 is still 0.5, and that's to the 5 minus 2 power, or the 3rd power. 0.5 to the 3rd power times 0.25 times 10 is 0.3125. So the probability of getting 2 heads is 0.3125. Now the probability of getting 3 heads. That's equal to 5 choose 3 times 0.5 to the 3rd power times 1 minus 0.5 to the 5 minus 3 power. Now 5, choose 3, or how many different combinations of 3 items out of 5 can I choose? That's equal to 10. 0.5 cubed, that's equal to 0.125. And that's multiplied by 1 minus 0.5, so 0.5, to the 5 minus 3 power, or squared. This is all equal to 0.3125. 2 more to go. Now we want to try to find the probability of getting 4 heads if I flip a coin 5 times. That's equal to 5 choose 4 times 0.5 to the 4th power times 1 minus 0.5 to the 5 minus 4 power. 5 choose 4, that's equal to 5. Multiply that by 0.5 to the 4th power. That's equal to 0.0625 times 1 minus 0.5, which is 0.5, to the 5 minus 4 power, or the 1st power. Multiply all these together, and that's equal to 0.15625. So the probability of getting 4 heads is 0.15625. Now lastly, we have to find the probability of getting 5 heads, or getting heads every time we flip the coin. So that's 5 choose 5 times 0.5 to the 5th power times 1 minus 0.5 to the 5 minus 5 power. 5 choose 5 is 1. 0.5 to the 5th power, that's equal to 0.03125. Multiplied by 1 minus 0.5, that's 0.5 to the 5 minus 5 power, that's the 0 power. So this is all equal to 1. So we have 1 times 0.03125 times 1, or 0.03125. So we found all of our probabilities for all of our different values of x. Remember, x is just the number of heads we get, but think of that as the number of successful attempts we get if we flip the coin 5 times. So this is our distribution, and if we want to express this as a histogram, it would look something like this. Notice that getting 2 heads or 3 heads have the highest probability, and then 4 and 1 have a similar probability, as well as 0 and 5. Since we have a 50-50 chance of getting heads each time we flip the coin, we would expect that somewhere around half the time we would get heads. Now when we talk about binomial distributions or probability distributions, there's one last thing we have to be aware of, and that's that there are different types of distributions. The most common types are the symmetric distribution or the skewed distribution. Notice that the symmetric distribution is symmetrical across the center, or the most likely probability. Outcome 3 in this case is our most likely probability, and then the probabilities reduce at an equal rate as we move away from that most likely outcome on either side. Or think of, I can draw a line down the middle of this symmetric distribution and see that it is indeed symmetrical. The other type of distribution is the skewed distribution. That's when the probabilities tend to increase on one side of the distribution and not the other. So now that we've talked about the different types of probability distributions, that completes the tutorial on binomial distributions.